This video is the area of a segment. If you don't know what a segment is, or you don't know how to find its area, don't worry, because in 7.5 minutes time, hopefully you will be able to.
Well, first of all, we need to know what a segment is. That line there is a chord, and a chord is a line, straight line that meets the circumference in two places, and it divides a circle into two segments. The major segment, because that's the bigger segment, and the minor segment. Well, first of all, we need to know what a segment is. That line there is a chord, and a chord is a line, straight line that meets the circumference in two places, and it divides a circle into two segments. The major segment, because that's the bigger segment, and the minor segment.
As it says there, a sector is the area between two radii, radii being the plural of radius. So from the centre of the circle to the ends of the chord forms a slice of a circle, and that's called a sector. So on the left hand side we have our sector, and if we join the ends of the two radii, we split that sector into a triangle, and then the other piece we call a segment. Therefore the area of a segment plus the area of a triangle make up the area of a sector. And if we rearrange that, remember it's the segment area that we want. The segment area is the sector area, subtract the triangle area. There's our formula, a half AB sine C. Let's see what it means. There's our triangle. Let's label the vertices or corners A, B and C with capital letters. Doesn't matter which is which. But now what follows does matter, because opposite vertex A is side A, lowercase letter. Opposite vertex B is side B, lowercase letter. Opposite vertex C is side C, lowercase letter. Now in our formula we've got AB. What does that mean? Well, A and B are any two sides that you know in the triangle. And then sine C, well C, marked on our diagram in blue, would be the angle between those two sides. Therefore, if the two sides you knew were not A and B, but were, for example, B and C, then the angle you would need to know would be angle A. And then the formula would become a half BC sine A, where B and C would be two sides you knew, and A would be the angle in between. Let's see how that applies to this example. On the right hand side of the screen, first of all, because our triangle is made up of a radius here and a radius here, it's an isosceles triangle, so we know that other side must be 8 centimeters, and we can mark that in. Therefore, we know two sides of the triangle, and we know the angle in between the two sides. It's 110 degrees. Therefore, the area is a half times one side times the other side times the sine of 110 degrees. We tap that in our calculator and we'd round off to 3 significant figures. The formula we need is at the top of the screen there, that the segment area is the sector area subtract the triangle area. So we have our blue segment that we're trying to find the area of, that's on the screen. But in order to find that, we need the sector area. Now the sector is a fraction of a full circle. And that fraction is determined by this angle here at the centre called the sector angle. And that's 110 degrees out of a full circle, which will be 360 degrees. So 110 out of 360 is the fraction of a full circle that the sector represents. And pi times 8 squared would be pi r squared, i.e. that would be the area of the full circle. So we have a fraction of the area of a full circle, and that represents the sector area. Now, for the triangle area, it's a half times 8 times 8 times sine 110, which we've just done on the previous screen. 8 and 8 being the two radii, 110 being the angle in between the two sides, and therefore the segment area is the sector area minus the triangle area. So sector area minus triangle area, and that's our final answer. Here's example 2. The blue segment is marked in that we're trying to find. In order to find the area of that blue segment, we need the sector area. Now, it's important to note that this 255 degrees is the angle outside the sector. We want the angle inside the sector. Remember, 255 and the angle inside the sector must add up to 360 degrees. So the angle inside the sector must be 105 degrees. So the fraction of the circle, shaded yellow, is 105 out of 360. And then pi times 7 squared would be the area of the full circle. So we have a fraction of a full circle, and that represents the sector area. For the triangle area, it's a half times 7 times sine 105. 7 is one side, 7 is the other side, and 105 is the angle between those two sides. Consequently, to finish off, the segment area, which is what we want, is the sector area minus the triangle area, and we round off, as usual, to 3 significant figures. Here's the recap then. That's a sector, it's the area between two radii. That can be split up into a triangle and a segment, and it's the area of that blue segment that we want. And I think we can see that that segment area would be this sector area, the yellow sector area, minus that yellow triangle area. That would leave the blue segment area. So the area of a sector is x, the angle at the center, over 360. That represents the fraction of the whole circle, and pi r squared represents the area of the whole circle, so that's a sector area. The triangle area is a half AB sine C, where A is one side, B is another side, and C would be the angle in between. So A times B would be R times R, so that would become R squared, and sine C, sine the angle in between, would become sine X. So that would become a half R squared sine X. So the segment area is the sector area minus the triangle area, and there you have it.